Welcome to Algebra Examples. We're going to look at an example today where we are evaluating the limit as x goes to 0 of this expression here, 1 divided by x minus x squared, 1 over x squared plus x. And there is a lot of algebra that's going to happen in here for us to evaluate this limit. All right, let's dig in. So we have our limit as x goes to 0. Notice what we're going to have to do is we're going to have to somehow get these things to come together, these two fractions, because if we plugged in 0, which is our first thing that we should always do, we'd get 1 divided by 0 plus minus 1 over 0. And we can't divide by 0. That leads to badness. So let's disabuse ourselves of that notion. And notice that what we can do here is when we have an x squared plus x, we can rewrite that. So x squared plus x, we can yank a copy of x out of it, and we get x times x plus 1. So you'll notice if you distribute this x back in here, we get our x squared plus x. And I'm going to rewrite our second fraction in that new notation. Okay, so now we want to smush these two fractions together, which means we need a common denominator. And as you'll notice, by rewriting our second fraction, we can see exactly what we need to do. We need to multiply our first fraction by x plus 1. Now, if we multiply that on the denominator, we also have to multiply that on the numerator. We're going to leave that broken up like that in our second fraction. We're going to just not go back with that. All right, so in our fractions here, we have x plus 1 over x plus 1 minus 1 over x times x plus 1. All right, now that we have our same denominator, we can smush these together. So we have one fraction with the same denominator. On the top, we have x plus 1, and we are subtracting 1. Now that it's one fraction, the plus 1 and the minus 1 will cancel, which makes our life so much better. Now we have the limit as x goes to 0 of x is left on the denominator. That's what survives. And then x plus 1, x times x plus 1 in the denominator. And you'll notice we have an x in the numerator and x in the denominator. We can kill those off. They cancel each other out. Notice, however, we aren't left with a 0 in the denominator. There's that hidden number that always sticks up, that 1. So x by itself on the numerator is really x times 1. So we're still left with an x plus or a 1 on the top. So now we're looking at the limit as x goes to 0 of 1 over x plus 1. We come back, do our handy dandy trick. We always try and see what happens when we plug in 0 for x. And do we get something that makes sense? Yes, we do. Our answer to this question is 1. Thank you for listening.